we can use limit laws to formalize our understanding of limits a little bit and make our calculations more precise without just relying on tables and graphs. So to understand them, just think of them like this. Let's start with the sum law. The sum law is going to say that the limit of a sum is the sum of the limits. All of these other laws can be phrased in a similar way, but to understand what we're saying, just imagine that we have a function f whose value is approximately 3 near some a, right? And g whose value is approximately 9. If we add the two, it's expected, right, that the output will be approximately 9 plus 3, right? Approximately 12. This is what I'm saying on top here. So basically, I'm telling you this. If f is almost 3 and g is almost 9, then f plus g is almost 3 plus 9, right? Approximately 12. And this is true even if you're talking about products as well. And you can see that the way that I express myself in this in these notes is by saying, almost 3 could be 2.989, almost 9 could be 8.989, and then if you add the two, you get 11.998, which is almost 12. So that makes perfect sense. And you can do the same with the difference, right? So if you have the difference law, you can count that as being, and I have my calculator here to give an example. So if I have 2.999 minus 8.999, the result should be, right, the 0.999s cancel. That's 0.6, which is the same as 3 minus 9, right? So that's like 3 minus 9. That's minus 6. Constant multiple is one that works more or less the same way. Any c value, so let's say as an example, the limit of like 3 times f of x, if you use the example above, using the 2.999, right? That will be 3. So that will be approximately like 3 times 2.999, which is almost 3 times 3, which is almost 9, right? So that's the idea. The idea is that if something is very, very close to 3, for example, right, and you double that, then the result is very, very close to double of 3, right? That's the idea. So the same works with two products, and I can also outline that for you. For example, if 2.999 were multiplied by 8.999, right? Of course, the result is like 26.98, which is almost 27, right? Which is 3 times 9. So it's very, very close. So so far, these rules don't have any mystery to them. The quotient rule is something you have to be, or the quotient law is what we're calling them, right? The limit laws. It's important to keep our words straight. You have to be careful with the quotient law, right? Because you cannot divide by 0. So you have to be careful with what you're doing, and I'm going to mark that in red. You're not supposed to be able to divide by 0. So you have to make sure that the function g, which is at the bottom of the fraction, is not approaching 0. So be careful with that. In terms of power, there's no mystery either, right? So for example, if you were to do, 3 squared equals 9. So if you were to do 2.999 squared, that would also be about 9, right? It's also like 8.994 or something, also about 9. So something very close to 3 squared, right, is also very close to 9, the result is, right? The root is one other rule that you have to be careful with, because when the root is even, right, n even meaning like a square root or fourth root or sixth root or something like that, you need to have the input of the function to be positive or at least non-negative. For example, you can't do, highlight that in red again. You can't calculate, for example, the limit when x goes to 1 of the square root of x minus 2. You cannot do that. And that's because when x is close to 1, this thing inside is 1 minus 2, which is minus 1. It's negative. So you're not allowed to do that computation. This is just another thing to be careful with. Okay, let's do this example there at the bottom. And let me get rid of my calculator because I won't use it anymore. Gives us some extra space. So let's do that. So we're doing this. We're doing the limit. We're given the limits separately. The limits for f, for g, and for h. We're given each of those separately. All when x approaches 3. That's important. And now we're asked to calculate this whole limit when x approaches 3. And again, like I said, it's important that these are all the same. The x is approaching the same value for all of these. So let's go one law at a time. So I'll start by saying, okay, I have a fraction. Okay, so I'll use the quotient law. So this equals, take one limit at the top and one limit at the bottom. Make it my eraser a little smaller. So that's going to be limit x goes to 3 of one limit on top. So put one limit on top, one limit at the bottom. That's me using the quotient law. Some books will number those, and you can use the right numbers there, but I prefer to use their names. It's more instructive, in my opinion. And then that equals to, okay, what will I do on the top? I will put this limit inside of the root, because I know g and h, g is close to 8, and h is close to 18. So whatever this is close to, this is greater than or equal to 0, right? I also had to pay attention to the values when I was looking at the bottom. In fact, when f is 14 and g is 8, this is not close to 0, this thing at the bottom. So I'm allowed to do that. This limit can't be close to 0. If it was 0, I'd have to cancel my entire calculation and think of something else, but I always have to check that as I'm doing the calculation. So let's continue. Now on the top, I'll use the root law. So that will be the limit, or the root of the limit, to be able to put that in. And at the bottom, I use the difference law first. So that will be the limit. I'll space my calculations out a little bit further. In fact, let me do it now. I'll just move it down a bit. So at the bottom, I'm using the difference law first. So I used root law and difference law. And remember, to use the root law, I have to check that whatever is inside a root or square root is not negative. Just writing a note there to see what I did. I'm almost done. I can use first on the inside of the root. Now I can use the product law. Let's split this product into two. So I've used the product law. And at the bottom, I will use the constant multiple. Because the 2f becomes 2 limit, right? Limit of 2f becomes 2 limit of f. And now, that's great, because I know each of those three values, g of x, h of x, g of x again, and f of x, right? So it's just three different values. And let me split my screen so I can use this extra space. So that equals to square root of, so the limit of g is 8. The limit of h is 18. The limit of f is 14 minus the limit of g is again 8. So I just have to compute this. Let's actually do that. So 8 times 18, I have my calculator now on me. 8 times 18, that equals 144. That's great. I know that that has an exact root. And the bottom will be 2 times 14, that's 28, minus 8, that's 20. So that will be 12 over 20. I can simplify those by 2 each. Get a 6 over 10, which is a 0.6. So that's my answer. I can get an exact answer, even though the beginning was a very complicated expression. I was able to find that. A couple observations. Number one, you won't need to justify this for the entirety of a calculus class. That's not necessary. You start at the very beginning listing which rules you're using, because it's the beginning of a calculus class and the teacher wants to know what you know and what you're using, that you know what you're using as well. Specifically, that you're checking for the conditions that need to be checked for each law. But as a calculus class progresses, you won't be asked to do that anymore. That's the first. Furthermore, you won't be asked to do these many steps either as your calculus class progresses. And finally, another observation is, note that I wrote all my limits carefully. Right? Every time I wrote my limits, every time I repeat them, and I also add the little x tends to at the bottom. You have to keep writing that to be mathematically precise until you've actually plugged in the limit value. Until you plug in, so note this is where I don't write limits anymore. That's because here I've already plugged in the values for the limit of f, so I'm no longer calculating a limit. I've already found the limit value, so I can stop plugging them in now. So that's it. That's how you use your limit laws. Pay attention to that, and I hope this was helpful to you.